Hi, I'm Caitlin,
And I'm Katie.
and welcome to our new internet series, Quick Science with K-Squared.
For our premiere episode, we will be discussing semantic neighborhoods to explore the question of how we choose the right words when understanding speech.
Let's start with a description of semantic neighborhoods. Our mental representations of meaning are organized into neighborhoods of semantically related words. For example, the word cake exists in a neighborhood with related words like sprinkles, frosting, and sugar. When we go to activate one word, the neighbors get activated too. This is called spreading activation.
This goes hand in hand with semantic priming, which is when the spreading activation has reached the whole neighborhood. This was discovered by Meyer and Schevaneveld in 1976 here at U of M. Go Blue! We see evidence of semantic priming in lexical decision tests, in which participants see or hear words and are asked to make judgments on whether it is a real word or not. Sometimes the words that follow are related, other times not. Let's look at this study by McNamara and Altoriba. They found that when participants saw a word like leg, they were quicker to recognize other body parts like arm, knee, or foot, all mental representations in the semantic neighborhood of body parts.
This process seems automatic, but it's actually a lot more complicated. Lexical access happens in 3 stages: activation, competition, and selection. We explored activation with the Meyer and Schwanevelt finding, but let's take a closer look at competition and selection. After the correct neighborhood is activated, we still have to choose the right word out of the network. In the competition stage, all of the mental representations in the neighborhood compete with one another to determine what is the best match to the target. In the selection stage, one of these wins the competition.
Wow, who knew choosing our words was so cutthroat?
We often take for granted how smoothly this process goes, but we gain a lot of insight into its complex nature when something breaks down. We see this in patients with Wernicke's aphasia, a type of aphasia that is characterized by fluent speech that doesn't make a lot of semantic sense.
For him,
So we're on a cruise and we're about to
we
get to
will
Juneau.
sort right here, and they'll save their hands right there for them.
And what
Let's look at the science behind it with a study by Milberg and Blumstein. They saw that those with Wernicke's overall are slower in recognizing a word compared to those with Broca's aphasia and normal brains, but still have a faster response to related words. This demonstrates semantic priming, meaning that the activation stage is intact, but there is something amiss in the later stages. The correct neighborhood is activated, but they have greater difficulty in the competition stage, which in turn affects their ability to make a choice in the selection stage.
Eye tracking technology can further show issues in the competition phase in aphasic patients. These subjects listen to descriptions of words shown on the screen, just like this, and their eye movements are carefully recorded. If the patient has trouble with competition, they may have trouble fixating their eyes on the target if there's a semantically related picture on the same screen. The results of the study shown here show just that, where, upon hearing the word cherry, their eyes take longer to fixate on the target because their eyes keep getting drawn to a semantic competitor, a banana. There's trouble with competition in the fruit semantic neighborhood.
So, by looking at the deficits in those with Wernicke's aphasia, we can clearly see the 3 key roles in lexical access that are so important to recognize and use words in a semantically correct way.